Hello and welcome to our webinar. This is the first webinar in BCLP's Early Warning Sign series, Design Defects and How to Respond. I'm Alex Clough and I'm a partner in BCLP's London office. I've been advising global contractors, subcontractors and employers on their construction disputes for over 10 years.
And I'm Marcus Birch. I'm an Associate Director, also based here in London.
We're both members of the Global Construction Disputes team here at BCLP. Our team of over 90 construction experts work from 13 offices globally, helping clients keep control of their major construction and engineering projects in over 40 different countries. Before we start, two quick housekeeping points. First, you'll see a toolbar on the left-hand side of your screen. You can use this to ask us private questions on any of the issues raised today, which we encourage. We'll get back to you with an answer as soon as possible. Second, there's also a handouts area where you can download our recent report, Spotting the Risks in Construction and Engineering Projects. Some of you may have already seen that report, which examines 10 of the most common early warning signs that can often lead to disputes. This webinar series takes a deeper dive into 3 of those warning signs: design flaws, construction programs, and ineffective project management, looking at how to prevent these all too common problems. So, without further ado, let's get started. Today's webinar is all about managing and responding to design issues at all phases of a project. We're going to talk through early design through to structuring the deal, defects during construction, completion and commissioning, and then the post-completion phase. We are going to illustrate the points with a fictional case study, which will run through this whole, all the phases of the project. It is fictional, but based on true events that we've come across in cases that we've worked on. So let me introduce the Power Tower, which is a 4 gigawatt coal and biomass fired power station in the Middle East. It's the arrangements, the contractual arrangements are governed by English law, so we'll be talking on that basis. Now, the first physical work which the contractor needs to undertake on this project is to install the foundations. The design which the contractor has been given relies on 2 geotechnical surveys from 2008 and 2015. They say that the ground conditions are a mix of soil and sandstone with some granite intrusions. The employer recognises that these 2 surveys are old and they were limited in scope at the time they were done. So the very first task for the contractor is to complete a comprehensive survey to verify the design. When the contractor does this, the survey results show a different ground conditions to those in the earlier survey, and as a result, the design that the contractor has been given for the foundations is defective. So this needs a redesign of the tower foundations and additional concrete. And as a result, the contractor claims an EOT for waiting for the redesign and procuring extra concrete. Marcus is going to tell you a bit more about how you can deal with these types of problems.
Thanks. So in the early design phase, the focus should be very much on avoiding the defects. And how this is done in complex international projects is by the way of a front-end engineering design. It's important to spend time planning, and this is how you do it. You spend a year, maybe 2 years, on the front-end engineering design. That's a step that's between the conceptual design and the detailed engineering that typically goes in to the EPC contract. It's an exercise in establishing the cost, but it should also be an exercise in identifying design constraints and design risks. It's important not to minimize this phase because it can have a disproportionate impact on the time and cost of execution. That process should involve all the stakeholders, and crucially for present purposes, the contractor who will be responsible for the detailed design. Another common tool that's used in 2-stage contracting is a pre-construction services agreement. Now that can include services such as design verification, risk assessments. It can involve value engineering. That should involve not just the contractor working alone, but also in tandem with the employer side design team. Now the objective of the pre-contract phase, the early design phase, is to identify the constraints and develop the performance requirements for a plant. One should be thinking of developing not only the outcomes from the commissioning and qualification stage, but also the processes involved in that. How is the plant going to be tested? How are we going to assess whether it meets takeover? Now, moving on to the contract stage, The priority here should be fixing a clear allocation of responsibility for design defects. Now, in some of the contracts we have seen, which we hasten to add were not drafted either by our team or by our clients, this was not done too well. Now, we've extracted a couple of problematic pieces of drafting. The first two clauses that you see on this slide, which we found in a UK commercial design and build contract, demonstrate a problem in the making for this project. Clause 5.2 says the contractor shall be responsible for all the design, whether by him or the employer. That's the typical assumption of all responsibility that employers go for when they're trying to create a single point of responsibility for design issues. But unfortunately, 6.1.2 crept in, defining as employer's liability other elements designed by the employer or those for whom he is responsible. Two more clauses, which we found in an international contract for the sale of power plant equipment, pose a perhaps less obvious problem. There's an attempt to define the CDP, or the contractor's design portion, by reference to elements of the plant, but it does it at a rather higher level, as you can see: boiler, steam drum, feed pumps, and that's going to pose some problems later in the project, and Alex is going to talk you through some key issues and tools in terms of attributing risk for design defects at the contract stage.
So, as Marcus says, the most important thing is to consider who's responsible for which aspects of the design and make the drafting clear. There's a fundamental decision to be taken at the start as to whether the contractor is responsible for the design or not. So whether it's a design and build contract or an EPC type contract, or whether you're going down a more traditional route where the contractor is not responsible for design. If you go down that more traditional route, then you need to think about where is the line drawn. At what stage is the architect or engineer supposed to provide the design to the contractor? Because there will inevitably be some element of design that the contractor needs to take forward, and there might also be a portion of the design that the contractor is entirely responsible for. We've seen on a number of projects where there are multiple designers, for instance, an architect and an M&E engineer and a contractor, where there can be either a black hole where nobody's responsible for a particular element of the design, or sometimes, which can also pose a problem, where there's overlapping responsibilities for a design, where you've got 2 or 3 parties responsible for one element of the design. And in practice, that doesn't work very well because nobody takes overall responsibility, and it can lead to defects creeping in. We particularly see this on M&E works. Once you've decided who's going to be responsible for what, then you need to think about what standards need to be met. An engineer or an architect will usually be responsible for exercising reasonable skill and care. A contractor's design elements might be limited to reasonable skill and care, or the contractor might be required to achieve a certain performance requirement or ensure that the project is fit for some particular purpose. And if you're going down that route, that purpose or the performance requirements need to be very clearly specified in the contract. So moving on, we are past the design phase of the project. We've entered into the contract and the project is well underway. And as you might expect in this case study, there's a problem. The boiler's been installed upon the structural steel and the structural steel starts cracking. So you'll remember from earlier that the contractor is responsible for the design of the boiler, and this is where that wide drafting becomes a problem, because it's not clear whether the boiler includes all the ancillary parts of the installation, including the pipework and the structural steel that holds up the boiler. It's, so the contractor says that the structural steel is not part of the boiler, so it wasn't included in its design portion. The employer disagrees. And there's an argument about what the problem actually is. Is the steel too weak, or is the boiler too heavy? And if everything was clearly the responsibility of the contractor, then that kind of argument wouldn't arise. The employer in this situation, to avoid delay, commissions its own engineer to revise the design. And that's, and Marcus is going to tell you about some of the problems that can lead to.
So, okay, defects during construction, what can we do about it? Well, there's three things we do. We spot them, we flag them, and then we try to fix them. The first thing is to look out for warning signs. Warning signs on a building site usually involve unexplained slow progress in a particular area of the works, a series of requests for information in a particular area. But even without those more sort of unofficial warning signs, it's important to have design issues as a standing item in your progress meetings, to have suitably qualified attendees that can ensure that design issues are flagged at an early age. Now, once they're flagged, they should be notified. Now, most of the international contract standard forms will require notification in a particular form. If you look at clause 20 of the FIDIC red and yellow books, we'll set out the notice to be made if a contractor is to make a claim for time and cost. Alternatively, the NEC system has a rather more thoroughgoing system of early warning notices. And there's always two ways to approach the contractual notices. Certain stakeholders in the industry regard them as rather contractual in a negative sense of being protecting one's position and being aggressive and contractual. The modern approach is to regard them more as a collaborative tool in order to identify issues for the project so they can be addressed promptly. Of course, contractual notices have both purposes and are useful both in a project context and later on in a dispute context. Now, the way that a design defect that arises during construction is dealt with will depend to an extent on the allocation of responsibility that we talked about. Where the contractor is responsible for the defect, the rule in English law is there's no breach of contract until completion. So in principle, the contractor has the whole contract program to work through, identify a design solution, implement that design solution. That's subject, of course, to the obligation to proceed regularly and diligently and to keep working until completion. That rule as to the date of breach is also important in disputes context. For statutes of limitation, time doesn't begin to run until the breach, and so it does not run here from when the design issues arises, but rather from PC. Turning over to the other type of design issue, where the design issue arises on the employer side, the contractor is entitled to a variation or a change order. Now, where design issues lead to delay, you can then have a dispute about what delay has been caused by the design issue or what cost has been caused by the design issue. And it's important to keep on top of the program and have a clear idea about where this design issue is going to go, whether it's going to cause a delay to just an activity or rather to the whole of the works, and therefore assess the risk to the whole project. Now, as to the last bullet point on that slide, as to discrepancies in the contract documents, we saw earlier quite a clear conflict between two clauses in the power tower contract. A more difficult issue you have in the design context is when you have discrepancies or direct conflicts between different parts of the contract. So there might be one provision in the employer's requirements that doesn't tally with another in the main part of the contract. And this has come up in a lot of case law in the UK, elsewhere, most famously in the MT Huygar decisions in the UK, which was in interplay between a 20-year design life clause and specific obligations to comply with specified international standards. Now, in the English law context, they're typically resolved by way of reading the contract together, trying to make everything fit and making it consistent where possible, which often leads, in practice, to a cumulative set of obligations for the contractor so that he has to comply with everything. Such issues are often dealt with also, depending on the wording, by order of precedence clauses that tell you which bits of the contract are more important than others. But typically an English court will seek not to apply those clauses, but rather read everything consistently so far as possible. Now, from a project risk management point of view, these design issues that arise during construction need to be brought into the open and to be resolved by discussion. If you're going to resolve them by discussion and by cooperation, one thing to be careful about is to taking too close involvement in the other party's obligations, which can lead to an assumption of responsibility, a waiver of rights, or something dangerous from your own position's point of view. An option in those sorts of contexts would be to resolve particularly important design issues by way of a DAB or an independent expert who might step in to resolve the conflict. So getting back to our tower, and we're reaching completion after nearly 2 years of hard work. The power plant's nearing completion. The teams reinforced the structural steel underneath the boiler. sorted out the inconsistency in the fire stopping, and were more or less to time. But as so often, there remain a great deal of snags, in fact, over 1,000 minor defects, and one major defect, which is that while this 4 gigawatt plant has 2 phases that can each reach 2 gigawatts independently, when run together, for reasons nobody understands, they can rarely top 3.6 gigawatts and barely ever touch the 4 gigawatts required. Meanwhile, the employer's remedies are limited in that his liquidated damages have been capped out, the contractor's limited on liability has been reached, and no one has a solution to the problem of capacity anyway. The employer is keen to get on and certify practical completion, and the contractor is unwilling to get back onto site. And Alex is going to tell you about how to handle defects arise in this commissioning and completing phase, including those that can't be resolved.
Yeah, so when you get to the end, it happens very often, in fact, probably in the majority of projects, that there are still some patent defects there and possibly some latent defects. Now, the latent defects, by their very definition, you don't know they're there. There's nothing you can do about them until, short of doing a proper survey to spot anything that you can. If they're truly latent, you won't be able to spot them, and they will need to be dealt with later on. In terms of patent defects, there's technically practical completion shouldn't be certified where there are outstanding defects, but the commercial reality is often quite different. There's very often a tension between the employer wanting to get into the site and start operating the plant, take occupation, start earning rent, all those types of commercial considerations. There's the issue of whether the LDs really properly compensate for the loss of not taking over. The contractor might be keen to get off site and have practical completion certified to stop its liability for liquidated damages. And then there's also the problem of, if there are outstanding defects, the contractor coming back to fix them, but having to work around a building or a plant that is in occupation. So what happens when you're in that position and you do want to take over? It's important to have a clear list of outstanding defects that's given along with the practical completion certificate or other certificate, which specifies what defects the contractor is going to remedy, whether there's any outstanding work that needs to be done, and the time scale in which the contractor is going to complete that work. Also needs to be clear what the access arrangements are for carrying out that work. Will the employer vacate areas of the site to allow the works to be done? Is the contractor expected to work around the occupier? Those things need to be thought about up front before PC is certified. And then, very importantly, the retention needs to be considered. You need to look at how much retention you've got, whether you need any more if you're going to be taking occupation with defects outstanding. And it might be a case that some of the final payment is withheld to cover those defects, and there might be a regime for releasing that during the defects liability period. So returning to our case study, the practical completion has been achieved, the employer has taken over, the plant is in occupation, all the commissioning tests have been carried out, things have moved forward, and you won't be surprised to learn that on this calamitous project, further problems have arisen. What happens is the operator has been using a feedstock that it obtained locally, but has realised that there's a cheaper feedstock that's available from a US supplier. So it tries this feedstock, and unfortunately the boiler breaks down because of the high carbon content of this feedstock. The contractor says, this isn't a defect, you've put the wrong fuel in. The employer says, it was supposed to deal with this kind of feedstock. I always had the intention that we might change the feedstock, but there's nothing in the specification on this, and the contractor blames the employer for using this feedstock and also for running the plant 24 hours a day, which in the specification it wasn't supposed to do. The second problem is that cracks appear in the chimney this is going to take a 2-week shutdown to investigate. And there's a question as to who's responsible for losses incurred during the shutdown and the costs of remedying the chimney, which Marcus is going to tell you all about.
Well, it's defects in this stage, which I often think are the hardest to fix, because practically speaking, you often have the contractor is often down to a skeleton staff at this point. The employer is often under pressure from the lenders, or pressure from stakeholders to get operational, and it's often that there isn't much energy in the team, not much resource in the team to deal with defects. And it's often at this stage that people are looking for solutions which don't revolve around resolving the defects so much as resolving the commercial impact of the defects. And so it's important to have a contractual process in place here and to follow it if you do. What happens here is that you need to identify whether it is still within the defects correction period. If so, the contractor must be given the opportunity to come back onto site. He has the right and the obligation to come back onto site to fix, remedy those defects. And of course, the employer, if the employer goes off elsewhere to find somebody else to fix it, will run into difficulties as to mitigation. If he spends more than he needs to and then seeks to claim that from the contractor will say there's a failure to mitigate and the employer won't recover his full cost. The tools within the contract include, as Alex was saying, the retention. You need to think about your limitation periods. As we said before, the limitation period run from PC, so keep that in mind. And really being very precise about what is the contractor's responsibility is important here. We walked through the power tower problem with the feedstock and the 24-hour operating. If there's nothing in the specification about a particular type of feedstock, it often will require specific expert evidence, expert input to identify whether the cause of the defect is in fact new feedstock or the 24-hour running or a third matter which hasn't been considered. And so root cause analysis becomes absolutely crucial for these sorts of defects in order to identify who is responsible and to what extent. Often in many cases where we get to is that an employer seeks damages instead. He might seek damages in order to avoid having to get that same contractor back on site and have it fixed by his own resources instead. After all, once the plant is operational, it's just a question of money and there's not always necessarily a need to achieve perfection. So it's over to Alex now to wrap up the session with some takeaways. So 6 key points to take away. The importance of undertaking an early assessment of design variables and risk, the ability, at the early stage of the project, you're spending the least amount of money, but you've got the greatest ability to influence the outturn cost, and investment at this stage usually pays dividends later on. When you've got your contractor lined up, decide who is designing what. Define all the terms, even the obvious ones, and make sure the scope of the responsibilities is clear. Think about how everything fits together operationally and legally. An issue that we often come across is where an architect has designed a building and there's a certain ceiling height, then the M&E engineer has to come along and fit all the M&E services within that ceiling height. When they don't fit, there's an argument about whether the architect hasn't left enough space in the ceiling void or whether the M&E engineer has failed to fit it all in properly and specify the correct equipment. That happens time and again. It's important to define where the boundaries lie. Don't forget design changes, which can come up during the course of the project, will come up. You need a process to deal with those and how responsibility is going to be allocated. It's important to define completion. What does that mean? When will the building be complete? And if you want to depart from what the contract says on completion, then think through carefully all the consequences of that. Finally, think about the worst case long-term scenarios. What's the worst thing that could go wrong, and plan for that. And if you plan for the worst and hope for the best, hopefully your project won't be as disastrous as this one that we've told you about. That brings us to the end of today's webinar. Thank you for joining us. We hope you found it informative and entertaining.
We know you're busy, so we wanted to stick to time. But if you have questions, please send them in and we'll come back to you as soon as possible. Thank you.
Thank you.